Hello. So today we're going to be doing a different problem. Once again, don't think it's on Leetcode. Not 100% sure, but don't think it's on Leetcode. But yeah, it's another breadth first search problem. And so today we're going to be doing find the minimum depth of a binary tree. The minimum depth is the number of nodes along the shortest path from the root node to the nearest leaf node. I guess for some vocab lessons, the root node is, where we start, and the leaf node is basically anything that doesn't have any children. So in this case, it would be 9, 11, and 5. There's actually two problems. The very first part doesn't include the 9 and the 11, but that's kind of irrelevant to the problem right now. This is just like, the general aspect of the tree. And so, yeah, I've already went ahead and imported DQ because we know we're going to use it. But aside from that, let's get started. Basically, we want to do the base case. If root is null, then we'll do if root is none, then we can return -1. Or like, well, we can return 0. We'll return 0 instead. Because there is no depth, right? And then if there's the root, then it would be 1. And if not, then it would be 0, right? That makes sense. Okay, so basically from here, we're going to want to create a queue like we always do using the DQ, which is why we imported that. Let me close that window actually. We're going to do queue.append root, and we're going to initialize a depth variable. I'm going to start it at 0, but that's only because at the beginning of our while loop, I'm going to increment it by 1. You can start it at 1 here and increment it by 1 at the very end of the while loop. It doesn't really matter. I think as long as you're consistent with it, it's fine. So depth is 0, we've appended the root, and now we're going to start, iterating through all of the nodes and finding which child of the root, or, perhaps it could be the root, which node is the first level at which we can find a leaf node, right? So we're going to do while the length of queue does not equal to 0. We're going to basically, this means we have a node. In the very beginning, we're going to have a node because we've checked if root is none, and it's not none, so we've appended it. So we're at least guaranteed to have one iteration of this loop, right? We're going to do length is equal to the length of queue, and depth is plus equals 1 here. Because the first time we come in, we're going to be tackling the root, and the depth would be 1, right? So 0 increment to 1, the length will be 1 because we only have the root here. And then now we're going to go ahead and handle it. So for I in range of length, we're going to do node is equal to queue.pop left because we want to pop it out first in, first out. So since we append to the end, we always have to pop from the front. And so with that, if node.left is none and node.right is none, then we can just do return depth. Because using the easiest example, the first one, which is the root, the depth is 1, the length is 1, so we go find the first thing. If both of them are none, then we can just return, which is 1. Otherwise, we'll have to go through this whole check if node.left is not none. Because if we don't return here, that means left or right is at least none. So we do queue.append node.left here. And if node.right is not none, then you do queue.append append node.right. Right? And then at the very end, you just return depth, because that's all you really have to do for this question. You just have to check if this is a leaf node. If it's not, then at least one of these. So this, oops, that's not what I wanted. Check if leaf node. If so, return depth, and then we'll only get here if not leaf node at least has one child. right? Yeah, I think that's all you really need to do. Yeah, it looks good. I guess we'll just run it now because, well, we're done. So yeah, let's right click, run Python file in terminal. Tree minimum depth is 2 and tree minimum depth is 3. So here we'll do, we'll actually change it up a little bit, problem 1, and we'll make this problem 2. Just so, it doesn't, at least we can be clear about what is being run. So yeah, problem 1 is where it's 2, 7, 1, 10, 5. Oh, not 2, 12. 12, 7, 1, 10, 5. So the 9 and 11 aren't part of the problem yet, which you can see here. So if you look at this, it's root, root.left, root.right, and root.right has 2 children, but root.left doesn't have any. So the minimum depth is 2, which is right here. And then you do root.left is now equal to 9, and root.right left is equal to 11. So now the minimum depth is now 3, right? Because the 9 and the 5 both qualify. Even though in our problem we would hit the 9 first, it doesn't really matter as long as we get the value right. And the minimum depth is 3. So with that being said, the problem is done. Thank you for watching.